Welcome, Hornets, and thank you for joining me today. I'm working on AP Calculus AB, assignment number 5, and we are looking at working with integration by substitution. So we'll be talking about the various substitution method processes that we have as we go through the problems from page 337. So we're going to be starting off with just identification, is what numbers 1, 3, and 5, 1, 3, 1, and 3 do. And we're given 8x squared plus 1, the quantity squared, and we have outside 16x dx. Now, they like to put parentheses around it like so, but it's okay. What I want you to notice is that this inside piece has a power of 1, a power of 2, and this piece has a power of 1. That's what we're looking for, all right? Now, don't worry about the coefficients that are in front. If they turn out to be exactly the same, it means we have no extra coefficients that we are multiplying by. If they're not, we're just going to make sure that we multiply by some value that will make the two pieces equivalent. And you'll understand as we go through. So let's go ahead and begin. We're trying to find what u will equal, and in this case, our u is going to equal 8x squared plus 1. We're then going to find what du is equal to, and the du is going to be equal to the 16x dx. That's number 1. Now, they're not asking us to do anything, they're just asking us to identify. Let's go ahead and go to number 3. Number 3 now gives us the tangent squared of x secant squared x dx. Now, in this problem, what we're trying to do is still the same thing. But stop and think a moment. What are we really looking at? This is tangent of x, the quantity squared. And we know that the derivative of a tangent is secant squared. Therefore, our u is tangent, and our du is going to be the secant squared x dx. And once again, my room has begun to leak. Well, let's go ahead and keep going. Hopefully, no electrical work gets wet, which might cause some problems for me. All righty, we're now going to number 5, where we are trying to find the indefinite integral and then check our results by doing the derivative. So I have parentheses 1 plus 6x to the power of 4, and I have a 6 dx. Once again, I see x to the first, and I see a constant of 6. So I'm going to let u equal 1 plus 6x so that du will equal 6 dx. Now you'll notice, normally we go u prime. Now we're looking at it as a du dx, and we're moving the dx to the opposite side over towards the right so that we get a differential. Now, by substitution, I get u to the 4 du. I'm now going to do my derivative 1/5 u to the 5th plus c, and I'm now back substituting. 1/5, 1 plus 6x to the 5th power plus c is my answer. Let's go to number 7. Now, as you get started, these really do get easier. I recommend that you do a few of them, even if you think you're getting good at it, because there are always little things that happen. And if you read my notes, you notice that there were 3 different possible ways in which we could use the u substitution here. So we have to be very careful. I'm getting a little concerned because I'm hearing the dripping in other places. All right. Well, the joys of life, right? So u equals, once again, I have a u squared. I have that x, or x squared to an x to the first. So I'm going to put 25 minus x squared. The du is then going to be 25 goes to 0, negative 2x, and we put the dx behind. We're now looking at u to the 1/2 power du, and I now get 2/3 u to the 3/2 power plus c, and I back substitute. Whoops, 2/3, and I have 25 minus x squared to the 3/2 plus c. And there's my answer. Let's go ahead and continue with number 9. Number 9 is the integration of x cubed x to the 4th power plus 3, the quantity squared, dx. See, the power of 4 to the power of 3, that's what we're looking for. Once again, here we go. U equals x to the 4th plus 3. Notice there's something different this time. We have a 4x cubed dx, but we have a 1 here. Oh no, we're going to have to get rid of that 4. So we're going to do 1/4 du equals 4/4 x cubed dx, and it gives me 1/4 du equals x cubed dx. So the idea is to take this value and simply move it over as a fraction. We're now going to go ahead and we're going to do our substitution. I like to now put the 1/4 in front. I then have my u to the 2nd power du, 1/4 times 1/3 u to the 3rd power plus c, 1/12, back substitute x to the 4th plus 3 cubed plus c. And we have our answer. Let's go ahead and take a look at number 11. Number 11, integration x squared, x cubed minus 1, and this is to the 4th power dx. We see the cubed, we see the squared. Immediately take u equal to x cubed minus 1, du equals, now we're going to get that 3, so I'm making it 1/3, and it's now x squared dx. Once again, the 3 that was here is moving to the other side as a 1/3. Once again, that's the easiest way to think about it. 1/3 now becomes 1/3 u to the 4th du, and I now have 1/3 times 1/4, 1/5, x u to the 5th plus c for 1/15, back substitute x cubed minus 1 to the 5th plus c. Now, I haven't been going back and doing that double check, which is to do the derivative and just check. Notice you do get 1/3. We then have, so 1/3 of x to the 3rd minus 1, it's now to the 4th, times 3x squared, and the 3's now reduce. And we're looking at x squared, x cubed minus 1 to the 4th, and we can see that they are indeed equal. All righty. So Hornets, I'm going to go ahead and I'm going to stop this video, and we will continue with this, looking at some other representations as we go. Please join me in part 2. If you found this helpful, please make sure you click like so that I know that this is useful. Thank you very much. Be well and be safe. See you in part 2. Bye-bye.